Now learning physics will be great fun with a physics teacher, a solution to all problems in physics.
The physics teacher.
Here we have two masses 8 kg and 12 kg that are connected at the two ends of a light inextensible string that goes over a frictionless pulley. Find the acceleration of the masses and the tension in the string when the masses are released. So in order to solve this problem, let's sketch it first. So we have this rigid support and we have this pulley, and this pulley is frictionless, this pulley is massless, string is massless. So we have an ideal situation for pulley and the string. This is mass m1 and this is mass m2. Say m2 is greater than m1. So m1 will go down and m1 will go up. Now what we have to find out, we have to find out the acceleration of these masses and the tension in the string. So let's first show the tension arrows. As the string is ideal, it is massless, so tension everywhere in the string is same. And always remember to use two arrows for the tension pointing away from the body. Two arrows for tension pointing away from the body and pointing towards each other. So it is the ideal way to represent tension. And what is the force acting on m1? It is m1g, the weight of m1, it is m2g. Clear? Now we have shown all the forces acting on the system, and in order to solve it we have to draw the free body diagram for both m1 and m2. So this is m1, force acting on it in downward direction is m1g, and this is tension T here. And for m2 you can write m2g downwards and this T upwards. Let it is coming down with an acceleration a, and this will move with an acceleration a in the in upward direction. So this is going up with acceleration a and it is coming down with acceleration a. Now apply Newton's second law in both the situations. So Newton's second law says the sum of forces is equal to mass into acceleration. So if you sum up the forces, and you can see that this force must be greater than this force, only then this mass will move up. So from here we can write T minus m1g is equal to mass into acceleration, and from this situation we can write m2g minus T is equal to m2 into a. Why? Because it is coming down with this much acceleration, and for this force has to be greater than tension. So if you add both these equations, you have to add both these equations, add it, so you will get m2g minus m1g is equal to m1 plus m2 into a. So from here you can write acceleration as m2 minus m1 divided by m2 plus m1 into g. So this is the required result, and if you put the values of m1 and m2 from here, you can have 12 minus 8 divided by 12 plus 8, 20 into g, that is 10. So you will get 2 meter per second square. Now in order to find the tension, put this value of a from here in any of this equation, and solving it you will get T as 2 m1 m2 divided by m1 plus m2 into g. So by putting the values you will get 2 12 into 8 divided by 20 into 10. So you will get tension as 96 Newton. So this is our desired result. And if we want to extend our exploration further, you can also ask that what is tension here in this string? What is the tension here? Let the tension here is T dash. And if someone asks you to find out this tension T dash, you can easily do that. What you have to do, you have to look at this arrangement. You have to look at this arrangement. Here, as the pulley is massless, so from here you can write T dash minus 2T is equal to mass into acceleration. The mass of the pulley is 0 and this pulley is also not accelerating, so this is 0. So from here you can write T dash as 2T, and we know that T is 96, so you can write 192 Newton. Clear? Or you can directly remember that this T dash is always double of this in such a situation. Now there is one more way to solve this. So the way is that if we exclude this pulley and we make these two masses in such an arrangement, or in this way, if we put these two blocks in such an arrangement, let in this direction the force is M2G and in this direction the force is M1G. Now what is the net pulling force? The net pulling force is M2G minus M1G. This is the net pulling force. And what is the mass of the system? It is M2 plus M1, and from here you will get the result for the acceleration. See, it is same. And if you want to find out the tension, use free body diagram for the situation. Now this acceleration is the common acceleration, and if you want to find out the tension, you can write M2G minus T, that is equal to M2 into A. This is M2 and this is M1. So if you solve it, you will get MT as M2 into G minus A, and if you put this value of A, you will get the T same as this result.